Explain why complexes formed from transition metal ions are coloured. So we need to remember that complexes are our complex ions. We need to remember that they absorb frequencies, and it's important that we get this bit right, of visible light, otherwise they wouldn't be coloured. D electrons, it is important that it's electrons in the D subshell, are excited or get promoted. And then the remaining colours or frequencies, if you like, of visible light that weren't absorbed are transmitted. The iron content of iron tablets can be determined by colorimetry method. Dissolve a tablet in sulfuric acid, oxidize all the iron to Fe3+. So all the iron becomes Fe3+. So whether it was iron or iron 2, it's going to become Fe3+. Convert the Fe3+ into a complex that absorbs light at the 490 nanometers. So remember that there are times 10 to the minus 9 times 10 to the 9 nanometers in a meter. It was made up to 250. Measure the absorbance of light at 490 nanometers with a colorimeter and use a calibration graph to find the concentration. Calculate the energy in joules. So we need to remember that the energy gap between these d orbitals is equivalent to h times frequency, which is equivalent to h times the speed of light divided by the wavelength of the light. So h, Planck's constant, 6.63 times 10 to the minus 34. The speed of light, 3 times 10 to the 8, divided by the wavelength of this light, 490, but we need it into meters. Nanometers into meters. And we put that into our calculator. We get 4.06 times 10 to the minus 19 joules. Describe how a calibration graph is produced and used to find the concentration of the iron 3 complex. So the first thing is that we're going to have to make a range of concentrations of the iron 3 complex, so like 0.1 molar, 0.2 molar, 0.3 molar, and measure their absorbance Then we're going to plot a graph of absorbance against the concentration. And then we're going to read the value for the concentration of a measured absorbance from the graph. So we're going to put our unknown in and read off it, get its absorbance and read off its concentration. The concentration of iron 3 in the solution is 4.66 times 10 to the minus 3 moles per decimeter cubed. Calculate the mass in milligrams of iron in the tablet used to make the 250 centimeters cubed solution. So we're going to work out the moles by doing moles are very clever. So our volume is 250 times 10 to the minus 3 into decimeter cubed times our concentration. I'm going to put that on our calculator. And then we're going to do mass is Mr. Moles. And so the MR is 55.8 for iron. And we're going to get 0.0650 grams. It wants our answer in milligrams. So we're going to multiply by 1,000 and get 65 milligrams.